Transpose of a matrix. Suppose we are given a matrix 2, 3, 4, 5. If rows are changed to columns, then it will become transpose. A transpose, it is also written as A dash equal to 2, 3, 4, 5. Here 2, 3 is written. They are written in a row. Now they are written in column. 4, 5 is written. Both are written in a row, and now they are written in column. Take another example. Suppose A equal to 1, 2, 3, 4, 5, 6, 7, 8, 9. If we write A transpose A dash equal to 1, 2, 3, 4, 5, 6, 7, 8, 9. Here row is 1, 2, 3. Here that row has become column 1, 2, 3. Then 4, 5, 6. Here it is 4, 5, 6. Then 7, 8, 9. 7, 8, 9. Symmetric matrix. A equal to A dash. Let's take some examples. Suppose the matrix is given as 1, 2, 3, 1, 2, 3, 4, 5, 6. Now, if we find A dash, so rows are changed to column. So 1, 2, 3. So like this. Then 2, 4, 5. Then 3, 5, 6. If you observe carefully, A and A dash are same. So this is an example of symmetric matrix. Skew symmetric matrix. A dash equal to minus A. Let's understand by an example. Suppose we are given A equal to 1, 0, 1, 2, minus 1, minus 2, 0, 3, minus 3, 0. And if we write A dash, so it will be 0, 1, 2, minus 1, 0, 3, minus 2, minus 3, 0. Now, if we multiply each term by minus 1, so minus A dash, so that would be equal to 0, 1, 2, minus 1, 0, 3, minus 2, minus 3, 0. Clearly, A equal to minus A dash or A dash equal to minus A. So this is an example of skew symmetry matrix. Show that elements of main diagonal of a skew symmetric matrix are Rj. So suppose A11, A12, A13, A21, A22, A23, A31, A32, A33 is a matrix 3 class 3. In a general way, we write the elements. Here in previous case, we have observed that if this is A1, 2, and this is A21. So they are negative oxygen. Similarly, here this is A13 and this is A31. They are negative of each other. So we can say that Aij is negative of Aj I. Here, this is A I J. So this will be A J I. Now we shift this term to LHS. A I J plus A J I equal to 0. But in case of main diagonal, the elements are like A11, A22, A33. So we can say AII. So here we have to put I equal to J. So when we put I equal to J, so AII plus AII equal to 0, or twice of AII equal to 0, which gives AII equal to 0. So this was the question, that elements of the main diagonals must be 0. So in case of skew symmetric matrix. And here, if you see carefully, you will find that the example that we've taken has the elements in the main diagonal 0. Now let's consider next thing. Creation of symmetric and skew symmetric matrices. Suppose we are given a matrix A, then A plus A dash or A plus A transpose will be symmetric. We can also write 1 by 2 A plus A dash is also symmetric. Similarly, A minus A dash or A minus A dash divided by 2 is skew symmetry. Now, let's understand it by an example. Suppose we are given A equal to 2, 3, 4, 5. Now, we find A dash. So A dash will be 2, 3, 4, 5. So A plus A dash will be equal to 2 plus 2, 4. This is 7, 4, 3, 7, and this is 10. So this will be a symmetric matrix. Suppose this is equal to P. So if we find P dash, we will get same thing. So clearly it is symmetric. Even if you write here 1 by 2 of that, this thing, so that will also be a symmetric matrix. Now let's consider the case of skew symmetry. So we are given A and we find A dash. So A dash or AT will be equal to 2, 3, 4, 5. And then we find A minus A dash. So A minus A dash means 2 minus 2, then 3 minus 4, then 4 minus 3, and then 5 minus 5. So we get 0, minus 1, 1, and 0. Here, elements of main diagonal are 0, and Aij is negative of Aji. This is A21, this is A12. Both are negative. And if you make half, still it will remain skew symmetric. A minus A dash divided by 2 will be 1 by 2 of same thing. Now let's solve one question. We are given a matrix of 3 class 3. Suppose 2, 4, 6, 3, 2, 1, minus 1, 2, 0. And we have to express it as a sum of symmetric and skew symmetric matrices. So first of all, we have to find out V dash. V dash means the rows and column. Okay, so it will become 2, 4, 6, then 3, 2, 1, minus 1, 2, 0. So to get symmetric matrix, we write 1 by 2 B plus B dash. So that will be equal to 1 by 2 and the sum of corresponding elements. So it will be 2 plus 2, that is 4, and 3 plus 4 is 7, and this will become minus 1 plus 6 is 5, then this is 7, then 2 to 4, and this will become 2 1 3, then 6, this will become 5, then 1, this is 3, and this is 0. Clearly, it is a symmetric matrix. Suppose we write it as P and we find P dash, so we will get same value 1 by 2 times, because 475, so 475, then 743, and then 530. Now, if we write skew symmetry, so for that we have to find out P minus P dash. So it will become 1 by 2. We have to subtract. So 2 minus 2, it will become 0. So elements of main diagram will become 0. Then 4 minus 3 will give 1. And this will give minus 1. Then 6 minus minus 1, that will give 7. So this will become minus 7. And then 2 minus 1 will give 1. So this will become minus 1. Clearly, if we write it as q, so and find q dash, so that would be negative of q. So it means this is skew symmetry. Now, if we find the sum of the two matrices, so 1 by 2 b plus b dash plus 1 by 2 b minus b dash. So if we open the bracket, we will get b. And if we find the sum of these two directly, so we will get this matrix 2 4 6 3 2 1 minus 1 2 0. So we can say that we can express any square matrix in form of symmetric plus skew symmetric matrices. So our purpose is solved. Question 3. If A equal to cos theta sin theta minus sin theta cos theta, and the condition is A plus A dash equal to I, then what is theta? So let's write it. A plus A dash, that is cos theta sin theta minus sin theta cos theta, and A dash. A dash means cos theta minus sin theta and sin theta, then cos theta. And it is given as I. I means unit matrix 1 0 0 1. Let's simplify. So it will become 2 cos theta 0 0 2 cos theta is equal to 1 0 0 1. So we can say cos 2 cos theta equal to 1, cos theta equal to 1 by 2, or theta equal to 60 degree, or pi by. Now, if A matrix A is both symmetric and skew symmetric, then prove that it is a zero matrix. So suppose A is a matrix and it is symmetric, then A dash must be equal to A. Now, if A is, so here this is case of symmetry, it is symmetric, then A dash must be A. Now, if it is skew symmetric, so A dash must be equal to minus A. Now, the two must be equal, since A dash equal to A and A dash equal to minus A. So we can say A equal to minus A, which implies 2A equal to 0 or A equal to 0. So our question was, if a matrix A is both symmetric and skew symmetric, then prove that it is a zero matrix. Obviously, A is a zero matrix. Thank you for watching.